Hello guys, today I am going to start a topic that is gravitation, and I am Anas Hussain and I am going to conduct this session. So this video is for only class 8 to 10. We will learn a very basic concept about the gravitation, but in future days I promise you will get to learn a very important topics as well. So now starts the topics. First we are going to know that what is the concept of gravity, okay, then why we need gravity actually, then how it exists in our daily life, and then finally who discovered it. Okay, these are the things we are going to study first. So let us consider a phenomena. First example, if we assume a boy and he is whirling a stone, okay, whirling a stone in this direction, what will happen after some times? If he stops moving the stone, okay, what will happen? The stone will fall downwards. It will never go upwards. Here we can feel gravity, okay. So here we can feel gravity. Now why we need gravity? Okay, if we don't if gravity doesn't exist, what will happen? This stone may fall randomly at any place, and that may cause a incident, and that will may hurt us also. So that's why we need gravity, and we have to study gravity, okay. And the universal of gravitation, okay, this is the main basic things what we have to learn, okay. What is the definition, or we can say what is the theorem or principle, that every object in the universe, okay, see, every object in the universe attracts every other object with a force which is proportional to, this is important, which is proportional to the product of their masses and inversely proportional to the square of the distance between them, okay. And the force is along the line joining the centers of two objects. For example, if this is a body and this is another body, okay, let two objects A and B, suppose this is A and this is B, and the mass of A is m and the mass of B is small m, okay, what will happen? There will be a force of attraction, and remember, gravity is always attractive force, okay, it never repels. In future days we will also learn repulsive force, for example electrostatic force as well. Now what will happen? A will attract B in this direction and B will also attract A in this direction, okay. Since this force is attracting towards each other, okay, and according to Newton's third law, which we will study later, we can say this force is same, and we have to find this force F. And universal of gravitation actually says that this force is directly proportional to product of their masses, okay, m into m, and also inversely proportional to the distance between them. See, if the distance is d between the two objects, then that is d square, simply. So if this is equation 1 and this is equation 2, okay, this is one number and this is two number. From these two equations, what we can say? F is directly proportional to m into m divided by d square. And if we remove this proportionality constant, what will happen? We will get F equal to g into m small m divided by d square. And what is g? This g is known as universal gravitational constant. That means its value never changes, okay. In the universe its value never changes, and the value is what? 6.67 into 10 raised to the power minus 11, and its unit is Newton meter square per kg square minus 2, okay. So this is the expression of gravitational force, okay. And here we have to know that inverse proportional law, inverse square law. What is inverse square law? This F is directly proportional to d square, that is distance square. In physics, whenever we will see this type of relation, we will say that this law obeys inverse square law. So we can say that gravitational law or gravitational force obeys inverse square law. In class 11 also we will get to learn electrostatic force. In electrostatic force also, we can see that F is inversely proportional to distance square. Okay, so electrostatic force is also a inverse square law, obvious inverse square law. Okay, I hope it is clear to you. Now we will apply this into a numerical. So this is a question from NCERT example 10.1. Okay, here the mass of the earth is 6 into 10 raised to the power, it should be 10 raised to the power 24 like this. Okay, so the mass of the earth is 6 into 10 raised to the power 24 kg, and that of the moon is 7.4 into 10 to the power 22 kg. If the distance between the earth and the moon is 3.84 into 10 raised to the 5 kilometer, we have to find the force exerted by the earth on the moon. That means this is earth and this is suppose moon. Okay, so there will be a force of attraction obviously according to universal law of gravitation, and we have to find this force of attraction. Here given mass of earth equal to 6 into 10 raised to the power 24 kg, mass of moon equal to 7.24 into 10 raised to the power 22 kg, and distance is what, 3.84 into 10 raised to the power 5 kilometer. Now we will bring it into SI, that is 3.84 into 10 raised to the power 8 meter. Okay, now what is FA? That would be G into ME MM divided by D square. Now put the values, you simply calculate it and you will get the value as 20.8 into 10 raised to the power 19. Okay, so we can say 2.08 into 10 raised to the power 20 Newton. Okay, so this will continue. Okay, we will always learn some theory, then we will apply into numerical, and this is very basic numerical, but I promise you in future we will get to learn a very important topics as well, and high level questions also. Okay.